All right, so today we're diving deep into oxygen.
Oxygen.
Yeah, all the stuff you sent over is
Right.
it's really fascinating.
Yeah.
So we're going to be uncovering how oxygen was born, how it got to Earth,
Okay.
and the impact it's had on, well, life as we know it, and maybe even beyond.
Absolutely. This is a story that goes back billions of years
Wow.
and touches on some of the biggest questions in science. You know, the origin of the universe,
Mm-hmm.
evolution of life,
Yeah,
search for extraterrestrial life.
all the good stuff.
Yeah.
So let's start at the very beginning.
Okay.
Where does oxygen even come from? I mean,
Well, believe it or not, the early universe, just after the Big Bang,
right,
was pretty much oxygen-free.
no oxygen.
It was mainly just hydrogen and helium, the lightest elements.
Okay.
And oxygen, as we know it, is a heavier element.
Right.
And it takes something pretty dramatic to create it.
Dramatic, like what?
Well, you could say that the factories are massive stars,
Okay.
much larger than our own sun.
Mm-hmm.
These stars have incredibly hot and dense cores,
What?
where nuclear fusion is happening,
Yeah.
atoms smashing together,
Yeah.
forming heavier elements.
Right.
And oxygen is one of the elements forged in these stellar furnaces.
So stars are creating oxygen,
Yeah.
but how does it get out?
Yeah.
They don't just deliver it to us, right?
No delivery service.
Okay.
Think of it more like a grand finale,
Okay.
cosmic fireworks show.
Right.
When these massive stars reach the end of their lives, they explode
Oh, wow.
in spectacular supernovae.
Supernovae.
These explosions are so powerful, they scatter the newly created elements, including oxygen,
Right.
far and wide across the universe.
That's where the stardust thing comes in, right?
Exactly.
We are literally breathing in elements that were once part of a star.
It really is mind-boggling
Yeah.
when you stop to consider it.
It is, yeah.
But the journey doesn't end there.
Okay.
The oxygen scattered by supernovae eventually becomes part of gas clouds that collapse to form new stars,
Yeah.
planetary systems like our own.
So that brings us to Earth.
Right.
But early Earth, not exactly a welcoming place.
Yeah.
The atmosphere, from what I've read, was pretty toxic.
Oh, absolutely. Early Earth was a harsh environment.
Yeah.
The atmosphere was a mixture of gases like methane, ammonia, carbon dioxide.
Not a breath of fresh air.
Not at all.
Deadly, really.
It would have been lethal to most life as we know it today.
Yeah. So how did this toxic wasteland transform into the oxygen-rich planet we know and love?
Right.
What happened?
Well, that's where things get really interesting.
Okay.
The story of Earth's transformation is intricately linked to the evolution of life itself.
Okay.
And we owe our breathable atmosphere to some of the earliest life forms on Earth.
Which are cyanobacteria.
Cyanobacteria.
Yeah.
I remember those from biology textbooks. They're
Yeah.
like those blue-green algae, right?
That's right.
And they're responsible for creating all this oxygen.
They are tiny, but they were true pioneers.
They evolved this remarkable ability, photosynthesis. Right.
Mm-hmm.
Through photosynthesis, they use sunlight, water, and carbon dioxide to create energy.
Mm-hmm.
And in the process, they release oxygen as a byproduct.
Sounds simple, but it had a huge impact, right?
Revolutionary.
Yeah.
Over millions of years, these cyanobacteria pumped oxygen into the atmosphere,
Right.
gradually changing its composition.
Okay.
And we call this pivotal period the Great Oxidation Event,
The Great Oxidation Event.
which occurred roughly 2.4 billion years ago.
So this Great Oxidation Event, it wasn't just the atmosphere changing.
Right.
It had like a ripple effect on the whole planet.
You're absolutely correct. It reshaped Earth.
Wow.
One of the most visible changes was in the oceans.
Yeah.
Early oceans were rich in dissolved iron.
Iron.
When oxygen became abundant, it reacted with this iron, forming vast deposits of iron oxide,
Rust.
which we know as rust, yeah.
So those massive banded iron formations
Yeah.
are like a geological record of this
How do-
oxygen revolution. That's amazing.
It is. The sky changed too, right?
Yes. Before the Great Oxidation Event, the sky was likely a hazy orange or reddish color
Really?
due to the composition of the atmosphere.
Wow.
But as oxygen became more prevalent, it began to scatter sunlight differently,
Okay.
giving us the clear blue sky we see today.
Wow, that's crazy to imagine, like a rusty ocean and an orange sky.
Yeah,
Earth must have been such a different place.
completely different.
So why oxygen? Could life have used a different element?
That's an intriguing question.
Yeah.
What makes oxygen so special is its chemical reactivity.
Reactivity.
Oxygen loves to react with other elements.
Mhm.
And this reactivity makes it fantastic for transferring energy.
Okay, how does that translate to life, though?
Think of it this way. Life needs energy to function, right?
Right.
Organisms obtain this energy by breaking down food molecules,
Yeah.
a process that involves transferring electrons.
Okay.
Oxygen is incredibly good at accepting electrons.
So it's efficient, making these energy-releasing reactions much more efficient.
So it acts like a supercharger for life's energy system.
Exactly.
Wow.
This increased efficiency in energy production allowed for the evolution of more complex life forms, eventually leading to multicellular organisms, and ultimately to us.
So without oxygen, life might have stayed microscopic.
It's possible.
Just stuck in those early, simple forms?
Yeah.
Huh.
It's fascinating, isn't it?
Yeah, so oxygen's reactivity is a key to complex life.
Yeah.
But too much oxygen can be a bad thing, right?
Absolutely.
It's like a double-edged sword.
It is. Oxygen's reactivity, while essential for life,
Right.
can also be destructive.
Oh, okay.
The rise of oxygen in the atmosphere was actually toxic to many early life forms
Really?
that had evolved in an oxygen-poor environment,
Wow.
sometimes called the oxygen catastrophe.
So life had to adapt to survive in this new oxygenated world.
That's right. Evolution's all about adaptation.
Mm-hmm.
As oxygen levels increased, life had to find ways to harness its power, while mitigating its dangers.
Yeah.
This led to some remarkable innovations.
Right.
One of the most significant being the evolution of mitochondria.
Mitochondria, those are the tiny powerhouses inside our cells, right?
Yeah.
Yeah.
Mitochondria are organelles
Mhm.
within eukaryotic cells,
Mhm.
the cells that make up plants, animals, fungi, and protists.
Right.
They're responsible for cellular respiration,
Respiration.
the process that uses oxygen to break down glucose and produce energy.
So every breath we take, every thought we have, every movement we make, it's all powered by oxygen.
Exactly, thanks to these microscopic mitochondria.
That's a remarkable synergy.
It is, isn't it?
Yeah, but the story of oxygen doesn't stop there.
No, it doesn't.
It's not just about individual cells or organisms. It's about this global cycle
Global cycle.
that connects the atmosphere, the oceans, and the land.
It does.
This global oxygen cycle, tell me more about that.
Sure.
How does it all work?
Imagine a complex, interconnected system where oxygen is constantly being produced, consumed, and recycled.
Okay.
It's a delicate balancing act.
Yeah.
It involves players from all corners of the planet.
So who are the key players in this global oxygen drama?
Well, in the oceans, we have phytoplankton,
Phytoplankton.
microscopic algae,
Okay.
responsible for producing about 50% of the Earth's oxygen
50%?
through photosynthesis.
Wow.
They're like the lungs of our planet, constantly breathing out oxygen.
Wait a minute. So every other breath we take is thanks to these tiny organisms floating in the ocean.
It is, yeah.
That's amazing.
It's a testament to the power of small things.
It is.
And on land, we have forests,
Right.
particularly rainforests like the Amazon, which
Mhm.
act as massive oxygen factories, absorbing carbon dioxide and releasing oxygen.
Yeah, the lungs of the earth.
They're often called that, yeah.
It really makes you realize how interconnected everything is.
It does.
But what happens if this balance is disrupted?
Right.
What if these oxygen-producing systems are damaged?
That's a crucial question.
Yeah.
And unfortunately, one that we're facing today. Human activities like deforestation, pollution, and climate change are putting significant pressure on the oxygen cycle, threatening the very systems that produce and regulate oxygen on our planet.
It's a sobering thought.
It is.
I've read about declining phytoplankton populations
Yeah.
in warming oceans, the devastating effects of coral reef bleaching.
Right.
These are serious issues.
They are, absolutely.
Yeah.
While we're not in imminent danger of running out of oxygen,
Okay.
disrupting the balance of the oxygen cycle has severe consequences for the health of our planet,
Yeah.
all the species that depend on it,
Right.
including ourselves.
It's clear that oxygen is far more than just a gas.
It is.
It's a story of cosmic origins, of the evolution of life,
Right.
and of the delicate balance that sustains our planet.
Absolutely.
But before we get too deep into the implications for Earth, I'm curious, what about beyond Earth?
Okay.
Could oxygen be a sign of life on other planets?
That's a question that has fueled the imaginations of scientists and the public alike.
For sure.
Finding oxygen in the atmosphere of an exoplanet,
Exoplanet.
a planet orbiting a star other than our sun,
Right.
is definitely an exciting clue.
So if we detect oxygen on an exoplanet, does that mean we've found aliens?
Not so fast.
Okay.
While oxygen is considered a potential Biosignature,
Biosignature.
a sign of life.
Right.
There are non-biological processes that can also produce oxygen.
Really?
For example, ultraviolet radiation from a star
Right.
can break down water molecules,
Oh, okay.
releasing oxygen.
So we can't just jump to conclusions.
Right.
Even if we find oxygen, it doesn't automatically mean there's life breathing it on that planet.
Exactly.
Yeah.
We need to be cautious and rule out other possibilities
Right.
before we can claim to have found evidence of extraterrestrial life.
Right.
It's a complex puzzle,
Yeah.
and oxygen is just one piece.
It seems like oxygen's story is full of twists and turns,
Just
from its
listen.
fiery birth in stars
Yeah,
to its intricate role in shaping life on Earth,
absolutely.
and even its potential connection to life beyond our planet.
It's a fascinating story.
We've covered a lot of ground, but there's so much more to explore.
There is indeed, and the deeper we delve into the story of oxygen,
Yeah.
the more we appreciate its profound significance,
Right.
not just for us, but potentially for life throughout the cosmos.
Wow.
Yeah. You know, it's remarkable how oxygen isn't just crucial for life on a biological level,
Right.
but it also plays a significant role in shaping human culture and history.
That's a great point.
Yeah.
When you think about it, oxygen has been a source of fascination, even reverence for humanity since, well,
Since ancient times.
the ancient times.
Absolutely. Consider our ancestors' relationship with fire.
Fire.
Fire, in essence, is a rapid oxidation reaction,
Right.
and its discovery was a pivotal moment in human history. It provided warmth, light, protection, and a way to cook food.
Great.
It's no wonder that fire was often seen as a sacred element,
Yeah.
a gift from the gods.
It makes you wonder, did those early humans have any inkling of the role oxygen played
Right.
in that,
In that mesmerizing dance of flames?
Yeah. Yeah.
It's hard to say for sure, but what we do know is that humans have long been captivated by oxygen's power.
Right.
Even today, it plays a vital role in countless aspects of our modern lives.
For sure.
Think of its use in medicine,
Medicine.
where supplemental oxygen is essential
Right.
for treating respiratory illnesses and supporting patients during surgery.
Yeah, and it's not just about keeping us alive, right? Oxygen is also a key ingredient
Oh,
in
absolutely.
many industrial processes.
Yeah, it's used in welding, metal cutting,
Right.
even in the production of steel.
And let's not forget its role in space exploration.
Of course.
Oxygen is a critical component of rocket fuel,
Exactly.
literally propelling us beyond Earth's atmosphere.
Yeah.
It seems that our thirst for exploration, our desire to reach for the stars, is also fueled by oxygen.
It is, yeah.
It's fascinating how something so fundamental to our existence
Right.
is also woven into so many aspects of our culture and technology.
Yeah.
It's almost like oxygen is a silent partner in human progress.
I like that silent partner.
Yeah.
It's a fitting description for an element that's often overlooked despite its profound influence on our lives.
Yeah.
And it's not just in technology and industry.
Right.
Even our language reflects oxygen's importance.
That's true.
We use phrases like a breath of fresh air to describe something positive and invigorating,
Yeah.
or gasping for air when we're feeling stressed or overwhelmed.
It's true.
Yeah.
It seems that oxygen has seeped into our metaphors and expressions,
It has.
reflecting its deep connection to our well-being
Mhm.
and our very sense of self.
Yeah.
It's not just a scientific concept. It's part of our shared human experience.
Indeed. But let's step back for a moment and consider a different perspective.
Right.
We've talked about what Earth is like with oxygen.
Right.
What if we imagine a world without it?
Yeah.
A world where the Great Oxidation Event never happened.
Okay, Earth, but hold the oxygen. What
Yeah.
kind of picture does that paint?
Imagine a planet dominated by anaerobic organisms,
Anaerobic.
life forms that don't need oxygen to survive.
Right.
These organisms would likely be much simpler
Okay.
than the life we see today.
Mm-hmm.
Perhaps single-celled organisms or small, slow-moving creatures.
So no towering forests or
Mhm.
intricate ecosystems.
It's hard to say for certain, but it's likely that life would be confined to specific niches,
Okay.
perhaps in deep-sea hydrothermal vents or other environments where oxygen is scarce.
I see.
The vibrant tapestry of life that we see today,
Yeah.
with its incredible biodiversity and complex food webs,
Right.
wouldn't exist without oxygen.
And what about humanity?
Right.
Could we even exist in a world without oxygen?
That's a question that goes to the very heart of what makes us human.
Yeah.
Our large brains, our active lifestyles, our capacity for abstract thought,
Mm-hmm.
complex communication, All of these require vast amounts of energy.
Energy
That is provided by oxygen-powered respiration.
So in a very real sense,
Yeah.
our very existence, our ability to think, to create, to experience the world in all its richness.
It's a gift from oxygen.
It is, yeah.
It makes you realize how interconnected we are with this seemingly simple element.
Yeah.
Oxygen is not just something we breathe.
Right.
It's woven into the very fabric of our being,
Wow.
shaping our biology, our history, and our potential as a species.
This deep dive has been full of surprises and insights.
It has.
We've journeyed from the fiery hearts of stars to the depths of the oceans.
It's been quite a journey.
Exploring oxygen's role in shaping Earth and the potential for its presence on other worlds.
Absolutely.
And it all comes back to the profound realization that we are part of something much grander than ourselves, connected to the cosmos and to the web of life in ways we're only beginning to understand.
I couldn't agree more.
Yeah.
The story of oxygen is a story of interconnectedness,
Right.
of the delicate balance that sustains life, and of the incredible journey that has brought us to this moment.
Yeah.
It's a story that reminds us of the wonder and fragility of life,
Right.
and of our responsibility to protect the precious gift of oxygen for generations to come.
It's amazing how something like oxygen, so fundamental to our existence, can be so invisible and taken for granted.
Yeah, we just go about our days, breathing without a second thought.
Right. We never really stop to think about all those intricate processes and cosmic events that make each breath possible.
Absolutely.
But, looking back at all this research, one thing that really stands out to me is how scientists can actually use oxygen, or rather specific types of oxygen, to understand Earth's history.
Oh, interesting.
Like detectives analyzing clues at a crime scene.
I like that analogy.
Yeah.
You're talking about oxygen isotopes, aren't you?
Exactly.
Yeah.
What's fascinating is that oxygen doesn't just exist in one form, right?
It doesn't.
These isotopes, like oxygen-16 and oxygen-18, they have slightly different weights. Due to the number of neutrons in their nuclei.
Yeah.
And these tiny weight differences can reveal a lot about Earth's past.
It's incredible, isn't it? How much information is encoded in these isotopes.
It really is.
For example, scientists analyze the ratio of oxygen isotopes in ancient ice cores.
Ice cores.
Extracted from glaciers and polar ice caps.
Right.
This ratio acts like a thermometer, basically, telling us about the temperatures that existed when that ice formed.
Thousands, even millions of years ago.
Exactly.
So we can actually trace the history of Earth's climate.
We can.
Including ice ages and warming periods. Just by looking at the oxygen trapped in ice.
It's like reading a history book.
Wow.
Written in frozen water molecules.
And it's not just ice, right?
No, not just ice.
Oxygen isotopes in rocks and fossils can also reveal clues.
Exactly.
About past environments.
Things like the salinity of ancient oceans.
Right.
Or the types of plants that existed in a particular era.
I was like having a time machine.
I know.
But instead of traveling through time, we're analyzing these tiny oxygen fingerprints to piece together the story of our planet.
Yeah, it's amazing what we can learn from these isotopes.
It is.
It really is.
But I can't help but wonder if we find oxygen on another planet, can we use these isotope ratios to determine if it's from, biological processes?
That's a great question. And it highlights one of the key challenges in the search for extraterrestrial life.
Which is?
While the presence of oxygen is a potential biosignature.
Right.
We need more than just its presence to confirm a biological origin.
Okay, so we need to analyze the specific types of oxygen, the isotope ratios, to see if they match the patterns we see on Earth.
Right.
Patterns that are indicative of life as we know it.
Exactly.
It's a complex challenge.
It is, but one that astrobiologists are actively working on.
Okay.
They're developing instruments and techniques to analyze the atmospheres of exoplanets in unprecedented detail.
Wow.
Hoping to one day find that telltale isotopic signature that whispers, life is here.
It's a truly awe-inspiring thought.
It is.
It makes you realize that we're on the cusp of a new era of exploration.
Yeah.
One where we might finally answer that age-old question.
The big one?
Are we alone in the universe?
Yeah.
And oxygen, the simple yet profound element, might just hold the key.
It's an exciting time to be alive, that's for sure.
It is.
But even if we never find definitive proof of extraterrestrial life, the journey itself is a testament to human curiosity, ingenuity, and our enduring desire to understand our place in the cosmos.
Absolutely. And speaking of understanding our place, this deep dive has really highlighted the importance of protecting the oxygen we have here on Earth.
It has.
It's more than just a gas. It's a vital part of this complex and interconnected system
Right.
that sustains life as we know it.
Absolutely. The story of oxygen reminds us that we're not just observers of the natural world.
Yeah,
We are participants.
that's a good point.
The choices we make today about climate change, deforestation, and pollution will have a profound impact on the future of oxygen and the countless life forms that depend on it, including ourselves.
So to wrap things up, what are some key takeaways our listeners should remember about oxygen?
Well, first, remember that oxygen is a gift from the cosmos, forged in the hearts of stars and delivered to Earth through a series of remarkable events.
Right.
Second, appreciate the intricate role oxygen plays in shaping life, from the simplest organisms to the complex ecosystems that make our planet so unique. And finally, let's recognize our responsibility to protect this precious resource, ensuring its legacy for generations to come.
Well said. You've provided an incredible journey through the world of oxygen, from its stellar origins to its profound impact on life and the search for extraterrestrial life.
It's been a pleasure.
To our listeners, I hope you found this deep dive as fascinating as we did.
Yeah.
And remember, the next time you take a breath, take a moment to appreciate the incredible story behind that life-giving gasp of air.
It's a good reminder.
Thanks for joining us, and until next time, keep exploring.